In order to graph this logarithmic function, I'm going to begin by describing the transformation, specifically the shifts I see based on the equation. Then I'll state the domain range and asymptote, and at that point I'm going to switch over to my graphing calculator in order to plot some points. To determine how my graph has been shifted, I'm going to look at the h and the k value, which will do what they've always done if you've been watching our other videos or paying attention in class. The h value is the number located within the parentheses. This number will be your horizontal shift, and it will do the opposite of what the graph says. So a -4 in the parentheses actually means my graph is shifted to the right 4 spaces. The k value is the number being added or subtracted at the end, not in the parentheses. This is your vertical shift, and this does what it says, so this will shift my graph up too. Well, knowing that is all I need to determine my domain, range, and asymptote. The range of a logarithmic function is always -infinity to +infinity. It'll always go down and up forever. My asymptote then is a vertical line, which means it's going to be x equals. Now normally it's x equals 0, but anytime you have a horizontal shift, that'll change where that vertical asymptote is located. So all I need to know is what my h value is to determine my new vertical asymptote. -4, we've already said, does the opposite of what it says it will do. So it'll move my graph right 4. So my vertical asymptote now is x equals 4. So let me actually go ahead and get that drawn in. 1, 2, 3, 4. So I'll have this dashed line where my graph will get really close to that, but it will never touch it or cross it. Kind of like a wall stopping where my graph can go. This also then helps me describe my domain. My domain is going to be from 4 all the way to infinity, from that asymptote on to the right forever. Now I use a parentheses because again I can get really close to that 4, that asymptote, but I can't quite touch it. That's about all that I want to do by hand. I mean, I guess there's one more thing I could note. Since I've got a base that's bigger than 1, I know the basic shape of this exponential curve will be something like this. If I had a number less than 1, my graph would go in the other direction, something like that. But to be a little more specific, I'm going to want to plot points. And at this point, I want to switch over to my calculator. I'll show you a couple ways that I can get this equation typed into my calculator in order to find some points to make a more accurate looking sketch. There's a few ways that we can get this logarithmic equation typed in our graphing calculator. By far the easiest way to do this is to use the log base button. Now, not all graphing calculators have this. In Y1, I've used the log base button to type this equation in exactly as it appears right here. If you do have log base, you'll be able to tell. If you hit alpha and then the window button, you'll see right there, option 5 is this thing called log base. If you select that, it lets you go ahead and just type in exactly what you want in the base and in the parentheses right there. If you don't have that option, there is a way to type it in, and I've typed that in Y2 down here. It's a little more complicated, a little more involved, but it works. To do this, you're going to use the log button, which all of you guys have on the graphing calculator right there. To do this then, you would type in log, type in anything that's in your parentheses over here, so log of x minus 4, and then divide it by the log of whatever the base is here, so divided by log 5. Notice I closed off the parentheses because I only want that base in the bottom of the fraction, and then this plus 2 just gets typed in at the end. I've done this using something called change of base formula, which we'll take a look at in more detail at another time. But from this point, I want to look at my table first to plot some points. So go ahead and hit second table, whichever way you've had to type that in, and you'll see I have the same values in both, so these are the same equations. You see a bunch of errors. Notice that's going to be the case anytime we plug a number in 4 or less, because there was no graph over there. We said there's a vertical asymptote. Most of your points will be irrational, nasty irrational decimals, because that's just how logarithms work, but you should be able to find a couple points that are nice in there. So I plotted the points 5, 2 on my graph, and I plotted the points 9, 3 over there. And I've noted in the previous part of this video, my graph, because my base is bigger than 1, will have this basic shape to it. Notice this graph does go downwards forever, but it never touches that asymptote, and it goes forever to the right. One thing I want to point out based on the graph itself, go ahead and hit graph. And you'll see a graph that looks almost sort of like this, but you don't see that this graph does go downwards forever. It does. This is probably the most common mistake I see people make because their calculator does not graph that part. They don't either. The reason the calculator doesn't do it is because the graph is so steep over here, it doesn't have enough resolution, enough pixels to actually graph that in there. So it's kind of a major flaw that one reason I hate graphing these on the calculator, but we need to be smart enough to know that because my graph does go downwards forever, the range goes to negative infinity, I need to do more than what the calculator shows me and make sure that on my sketch, this graph does go downwards forever, getting closer and closer to that asymptote.